Hello and welcome everyone. So I'll be explaining this problem right here of Codeforces, problem number B, ideal point. Basically in this problem, you're going to be given a bunch of range of numbers from L to R, just going to be given the two endpoints about the ranges, and also you're going to be given an integer called K, and what you have to find out, literally what you have to find out is whether you can make that integer k an ideal point or not. Now, what do we mean by an ideal point here? An ideal point, let's say that k value is 5. Now, when are we going to call this number 5 an ideal point? We can call this number an ideal point only when, out of all these numbers, only the number 5 contains the maximum number of ranges that we talked about in the first place. What were those ranges? The ranges that we're gonna take as input, as you can see, we're gonna take n ranges, and the number, the only number which is gonna have the maximum amount of ranges, which is gonna contain the maximum amount of ranges out of all the numbers, only that number is going to be considered as an ideal point. Now, one question might arise that there might be several ideal points. No, we're not considering several different numbers to be the same ideal point. Our ideal point would always be only one point. So we're gonna somehow have to manipulate the ranges to make our given k an ideal point, and we are allowed to do that. What we are allowed to do is we can reduce any number of ranges that we're given. We might consider not taking those ranges uh, of the ranges that we are actually considering and to take in the first place. So we have an option, and that option is that we might not take a particular range. We might erase that, and by doing so, we can reduce uh, integers having same number of containing same number of groups or segments. So in order to make k ideal, of course, we have to reduce some ranges if we find that, okay, it's not ideal enough, or if it does have the same amount of maximum number, or like same number of as several values containing same number of maximum segments, and we do not want that. We want it to be ideal. So we have to manipulate the ranges or raise the ranges somehow uh, to make k ideal, or to make k such that k contains the maximum amount of segments. So that's how we're gonna do this. And you see, the simple solution of this problem would be, as you can see, okay, let's take an example. A simple way to think about this problem is to consider only two ranges and reduce the rest of it. Now, which of the two ranges are we going to consider to take? Of course, they have to be the ranges which consist the number that we're taking. Let's say this is k, and we are only worried about ranges um, that belong the number k. So what are the two particular ranges that we're going to take into account? Is going to be a range that ends with k, any range, doesn't matter, and a range that begins with k. Doesn't matter which range it is. If we find two ranges like that, which ends with k and begins with k, then we're definitely sure that if we reduce the rest of the ranges, we have an answer. Why is that? Why we're not taking 4, 5, 6 as our ranges? Because if we do take it, the problem is, if we do take it, we will get same number of segments of same number of maximum number of segments. I hope you understand. There will be then a a number containing maximum number of segments, but the number will contain similar values. So we do not want that. We want it to be ideal, and so we're going to only consider these two ranges. Why these two sort of ranges do matter, because we're considering k, we're only considering two segments that ends with k and that begins with k. And by doing that, what happens is, take a look at it. This 5 belongs to two ranges, but these 4 and 6, they belong to only one range, because 5 is containing in between these two ranges, and it is only uniquely contains in between these two ranges. So that's why we're only considering to take these two ranges. We're only care about these two ranges like that. The two ranges that ends with k and begins with k. Just this simple observation that we need to find out here, and that's exactly what we did when we implemented this solution. As you can see here, we're taking LNR, and we're also taking some of the corner cases, but I don't think that actually does matter, because we are only considering to take the ranges which actually the two ranges that we talked about. And also there could be a one additional corner case where there might not be a range which is inside, which contains the number k. So in that case, the answer um, would be no, of course. And yeah, apart from that, the solution is just as simple as we talked about. We will only care about those two ranges, and that's all.